Hi, my name is Marcal Serrate. I live in Barcelona and I'm the CTO of Hybrid Theory, a digital service partner for brands and agencies. My speech topic is about how a rather small team of engineers can manage more than 300 million of events per day to support data-driven products for the advertising industry using Kafka, Spark, and machine learning. So I hope that you will enjoy the session. Welcome to the Big Data Architecture in the Advertising Industry session. My name is Marcal Serrate. I am the CTO at Hybrid Theory. I was previously working as a head of data engineering at AXA, and afterwards also in advanced analytics at Lido International Hub. My topics of interest are around big data, advanced analytics, and machine learning. Also here I have my Twitter contact. So what are we going to see today? A bit of introduction of what we do at Hybrid Theory, big data architecture overview, then we will zoom into the data components. Finally, also we'll review the machine learning projects and some Q&A as well. So we start, what we do in Hybrid Theory is we are a digital service partner for brands and agencies to help understand behaviors from their customers and also provide operations to run and optimize campaigns on their behalf. Hybrid Theory receive data from different sources, browse, search, and share, from an extensive network of publishers to be able to understand patterns and behaviors to create the best audiences for our clients. In terms of global data footprint, our numbers is we receive 2.3 billion of events per week. We have 210 million of users mapped every week. And all these data points usually are coming from browse and search and share, and usually geolocation data, device, or user agent such as browser, operating system, URLs, and more. So with that, let's see the technical details of the big data architecture. Even that it's covering the advertising industry, this can be translated to any industry as well. So what we have basically is in the left-hand side, we can see the data sources that's coming, as I said, from web browsing, mobile browsing, CRM data for first-party data, but also campaigns, pixels, ads, etc. And first of all, we filter out events from a GDPR CCPA countries. We use the Transparency and Consent Framework 2.0 in order to manage the consent strings. And then the data is collected in Kafka clusters. Basically, this is Kafka clusters on top of EC2 instances. So we manage around Kafka clusters here. So after that, we have the data enrichment consumers, which basically are written in Golang. And what we have is IP to geo services. Basically, what we do is to translate the IP address to a geolocation, basically region, city, zip code. When also, as we have a lot of different sources of data, we also apply some normalization to have some generic schemas. Then this data is stored in the data lake. And we also have some data processing, of course, process jobs. And one of them is for creating of audiences by using keywords and also contextual analysis, which is the category of the page. We also have Lookalikes, which is a machine learning model that finds new users by analyzing, browsing patterns and similar users' profiles. We'll take a look into that in more detail. Also, we have domain clusters, which is a machine learning model using clustering to categorize domains using the IAB taxonomy, and uses components such as work to bake and k-means for this clustering. Finally, we have the natural language processing layer, which is a product that we use to understand the main attributes of the pages that we see. And that's basically the core of our contextual targeting offer. All these data and processes are different services. We started with Amazon EMR, but we are now moving to Databricks, as it has better performance, do some custom optimization that Databricks does in their clusters. And usually we find like between 30–50% faster Spark jobs. So, it's a huge increase in to manage those jobs to use the Databricks clusters. Finally, we have also the data consumption part, which is we have the advanced analytics. We use Databricks notebooks for that, where the business users, but also data scientists, used to make data explorations and testing also new machine learning models. For the data warehouse, we are using Amazon Redshift. This is where dashboards and reports are being connected, so an aggregated point of view. And all those products and data processes that we do, finally, it's to do audience profiling and campaign optimization, media delivery, but also data enrichment for specific customers. On the data lake side, we have 3 layers of data. One of them is bronze, which is basically when we receive the raw ingestion that we receive from Kafka. Then we have the silver one, which is filtered and cleaned. This usually is the source from these audiences, lookalikes, projects, and also to be used as a feature engineering for machine learning models. And finally, the gold layer, which is the business level aggregate, which is to support the various business use cases that we have. Such as segments to be activated or campaign data. On the data lake, we are using Amazon S3 to store the data. And with the volumes of data that we have, we usually move data to Amazon Glacier, which is the cold storage to reduce the storage costs. Finally, also, we have these cross-service layers where we have the security and access for all those data layers, monitoring and logging. Basically, there is a lot of moving parts here, as you know, a lot of projects, a lot of jobs running in parallel. So we need strong monitoring tools in place to be able to determine when there is been a problem, when it had happened, to do retries if necessary, and also create real-time alerts. And last but not least, we have the metadata and catalog, which is basically where we store the description of the fields, so any business user that can access the Databricks notebooks, for example, they can understand what is the field that he's querying and what is used for. So that gives us a bit of overview of the data architecture in hybrid theory. Then we can jump into the review of the different data components. First of all, it's a quite important topic, which is the data lake. When we use cloud object stores, in that case, Amazon S3, there are some benefits. I mean, we have elasticity. You don't need to provision any resource. It's cost efficient. Usually it's 10 times cheaper than traditional HDFS. Availability and durability. Amazon claims that 99% of durability and availability. And also data lifecycle management. As we said, S3 can be configured to automatically migrate objects to cold storage after a configurable time period. But there are some problems with that. One of them is that object store is not a real file system, right? So there is a performance implication here. It's some sort of key value store, if I may say. So there is performance topics related to that. There is latency as well, network bandwidth, sequential input-output that makes latency higher and data throughput lower compared to traditional HDFS, for example. And data integrity, as we said, by not being a real file system, the lack of atomic directory, it's usually can house some critical problems as well, right, in the past. So how we are solving that? That's why we are migrating to Delta Lake or Data Lake. And what is Delta Lake? This is an open source project created initially by Databricks, although it's open source, but it's an abstraction basically to convert object stores to what it can be seen as a real file system. They are columnar, which it has good compression and performance. It's using Parquet, which is a format that we already know. We have used it for a lot of years in Spark. So that's something that we already know and we have experience with it. But it also have other benefits as well. So it provides ACID transactions. So every write is recorded in a transaction log. So that offers data concurrency as well. And we have something that we didn't have in the past, right? When we were using Spark, which is providing updates and deletes, which also simplifies other topics as well, like GDPR. So Delta Lake provides APIs to merge, update, and delete datasets. So easily to comply with topics like GDPR if you want to remove some rows, and also simplify change data capture. On a time travel perspective, there is support for data versioning as well. So usually it's useful for machine learning projects, as you can refer to a specific snapshot of the data for measuring model performance. And also if you are using evaluating the model, it's not being impacted when you receive maybe new data. As you also referring to a specific snapshot of the data. If you want to be a bit more of detail, one member of our team, Ruben Berenguels, wrote a detailed review of the Delta Lake paper. So I invite you also to check it out. Then on data catalog, we already said that we are using Amazon Glue for data catalog point of view. And basically this is a centralized meta store, is a Apache Hive compatible, and is quite easily to access it through and across the data lake. Also, it has seamless integration with a lot of services from Amazon, Amazon Athena, EMR, as we say, Databricks, but also Amazon Redshift Spectrum. So quite a lot of integrations that can use the same definition of the schema, right? There is on these last, I would say, weeks or months, also they incorporated DataView, which is a way to automate data cleaning and normalization tasks. We are not using it, we're just basically reviewing for the data lineage feature, which is something that we had in the past and something that we are reviewing right now. So that's for the data catalog, simple but very powerful in order to understand and to document the data. And also the data warehouse that we spoke before. Basically, we are using Amazon Redshift for that. And basically Amazon Redshift is an analytical database, it's very good at it. Also, it's very fast compared with other Hive or types of databases, but also it has some drawbacks as well. I mean, it's not meant to be used for pipelines or, because usually there is some congestion when we are using production pipelines on top of it to doing operational jobs and then other queries sharing the same cluster. So, and the other problem, big problem, is that there is no isolation between computation and storage. So it means that you cannot scale computation without paying for the storage, and you cannot scale storage without paying for unneeded CPUs. So this is some trade-off that you want to measure depending on your needs. And depending on your needs, you may also want to check other alternatives. Databricks now is launching also SQL analytics. So there are different alternatives depending on your needs. If you want, faster response and no waiting, to set up a cluster, usually the Redshift can be a good uh, candidate for that. If it's for other topics for managing and storing jobs, supporting your jobs pipeline, you may find better ways to manage this data. Finally, what we use to orchestrate all those moving parts. So we use Apache Airflow, which is a workflow scheduler using Python. It's very easy to track and schedule pipelines. Then you can also retries, and everything is managed through a console. It's easily integrated with a variety of services. It supports most of the services you might think of. And even with that, it's easy to extend or create new operators if you need, just, extend it using Python. We are integrated with most of our services. We are using for EMR, Databricks, Redshift, Fargate for containers. So there is a nice tool of integration there. So you can use it to orchestrate all those moving parts in one single pipeline. On our side, we are using also for Spark and Databricks as we're migrating our jobs to there. You can use it in different ways. From one side, you can use it to orchestrate notebooks if you want to test something. Also, GDBC, when you are migrating maybe from a Redshift query to a Spark SQL, you can use that just to not change too much code on your end. And then the recommended for production, basically it's jars. You are using Scala or Java, and will if you are using Python. So then you can also have your unit testing in your continuous integration, then push it, and the Airflow will use these jar or wheels to execute the Spark job. So this is what we use for Apache Airflow. So also just a reminder as well, when I'm going through all of that, is that we also have Slido. If you want to make Q&A, I'm going to checking it every now and then just to be sure that we are keeping up with the questions. I see that there is already one question. What can you tell about the depth SQL environments, their relevance for big data projects? Yeah, I mean, that's a very good question. In fact, this is something that you should take into account. Usually what we have is two environments. One, which is called Alpha, where we use usually a copy of production data, but also it is without any client's data, so privacy compliant way. And this is where we use to test the pipelines before pushing that into production. So yes, this is something important that you need to take into account. For the same reason, we have to also Airflow instances, one for the QA and the other one for production. So then you can manage to test everything in this continuous integration and continuous deployment pipes in order to be sure that you are deploying the right thing. So yeah, I mean, basically, usually in the data world, it means that you need to make different and copy of the data. Of course, it doesn't make sense to have a copy of all the data lake, maybe, just to have some amounts of data, that minimum ones, to be sure that your jobs are performing properly, but not too much, so not take too much time to execute. I mean, we have jobs that in production are ingesting millions of data every hour. So doesn't make sense there to for the Q&A to test the with a full amount of data. But yeah, I mean, that's something very important to have, that it's mandatory to have in place different environments to test your jobs, to test everything there, and all the continuous integration and continuous deployment pipes. Cool. So after that, I'm going also to show you very quickly what we use in terms of Databricks, as I was saying. In one hand, we have the Databricks offers you this data view, so which basically it's using, as we say, Amazon Glue, so you can know, okay, what an overview of your data. Here I'm using a sample table, just because not use all the amounts of data that we have, and even that it is small. I think I only took 1 or 2 days of data. It just 37 gigabytes of data. But also give you interesting things like the partition of columns, so you can use that in order to build your queries, and that behaves performantly, right? So use usually the region, so it can be Asia, Europe, or the US, year, month, and day, in order to separate the data in the right folders beneath. So that, as we said, this is using Amazon Glue for having the schema of the tables. Here you can see an example. So you have here the column names, the data types, but also the comments. So you can understand what is basically each of the fields. Then you also have here some sample of the data, so you can see also what's the table going on. If it's delta, a delta table, you also have the history, which is quite important. Is what I said before about the snapshot. In that case, we can see here the timestamp when it was created, who created it, which was myself, the operation that created it. So I did create a select, so I copy it from another table in that case, and the operation parameters, so the partitions, the notebook that launched this copy, this operation, and the cluster ID that launched it. So yeah, I mean, basically, it's quite helpful, that data that we can get using Delta. If we go on some examples, so yeah, I mean, if we can see that using this table, what we can see, Databricks also offers some inline plotting options. So yeah, for example, here you can say, just taking one region, for example, in the US, North America, we can see, okay, what is the distribution of our events for these, 2 days of data that I copied into this demo table. So you can see the number of events and the distribution of the events for each of the states of the US. So that's useful also when you want to doing exploration and you want to know what type of views you can get from the data. That's quite powerful. There are some type plots here in Databricks, but then you can also use your own, or whatever is your option. That just to have an example. If we do the example using Delta Lake, what I'm going to do right now is first create a shallow clone of the table that we were seeing before. Basically, it's a good idea if you don't want to mess up with data that you are using for other approaches. So basically, what we are doing here is creating another table, a shallow clone. So it's basically a clone of the previous one. And if we, they say describe history, we can see here the source that happened, the clone that we get, and also the update that we did, just in case that what we did before. So basically, is before launching this query, is that you can do updates using Delta. So in that case, you can update using one. For example, we have a column that says that is PC. So we are changing the name to desktop. So you can change the table semantics, for example, just using an update. Before, you needed to go, copy the fields, or maybe, updating, but copying in another table before removing the table. So you didn't have these, update semantics or APIs in Spark before. So this is, the power of Delta Lake. So now you can use query by this new field. And as we said, after doing this update, we also have the update and cloud. Yeah, this is happening because I didn't clean previously the table. So now we did both operations again. But basically, you can see that every time the version is going up, so we are keeping the versions and the snapshots of the data. So what happens if you want to query the old table, the first one, right? So I can say select, and here I can state this version as of 0, and here is when you state the version number. So this is the initial table. So here I can query by the PC instead of desktop, that I change it in the next version, as we can see here. So yeah, if I use now another version, it should send a message saying, yeah, I didn't find anyone, because now this version is called desktop instead PC. So yeah, you can see here how we updated a table in Delta, and we are keeping history. So that's quite powerful for things like machine learning, where you want to to measure performance by using always the same snapshot, but also evolve things. And like the example that we placed before about GDPR, yeah, you can delete rows, but you have the previous history in Delta Lake, right? I mean, what you can do, it's just use vacuum. By default is 7 days, but you can change it. So when you say vacuum the table, all the previous versions or snapshots are going to be removed. So that's a good way also to keep for data privacy tables, keeping the old versions, removing that from the history. So that's quite important. Okay, so if we move back to our slides, then we can review the machine learning projects that we are working at Ivory Theory. We have some of them. One of them is Lookalikes. I already mentioned a bit before, which the goal is basically improve the reach and conversion by finding similar users. So let's say that we have these brand converters, the red ones, right? That they purchase a specific product, let's say sports shoes. So the lookalike model, what's going to use, it's going to find all the users that share the same interest as people who already converted. So it's a classification model using the Ivory Theory universe. And let's say that these people that purchased sports shoes are people that usually browse for discount seeker, pet lover topics, or interested in financial blogs. So the lookalike model, it's going to find people that are similar to these profiles, shows that we can target them. The project we use is basically we are doing some ad hoc tokenization in the URLs that we receive. Then we do vectorization on top of it and a classification model using SVM. We also have hyperparameter tuning via grid search. And from a business point of view, what we can see is, the trader that creates the campaigns, can select which is the users that they want to find, to use as a seed. And then you can see here, it's some sort of ROC curve, but basically it's to find the trade-off between, the segment size, how big is going to be the segment, but the performance, right? So it's to find the trade-off. Bigger scale will mean, that less percentage of people maybe it's likely to convert, and having smaller percentage of the segment size, it's going to drive more conversions. That's why we say, you have your high value segments at the beginning and then your lowest value segments before afterwards. So basically, it's a bit how it works, the lookalikes model that we have. Basically, the main challenges that we have is, data scale. We have also high dimensions with relatively sparse data. And we're also always trying to improve. We also new features like doc-to-back embeddings. So vectorized browsing histories while keeping dimensions in manageable limits. Also, it's always nice to test, deep learning models. Although when we, do some type of test, usually see that the model that we are using right now is quite good in terms, cost efficient, but also performance-wise. So we are quite happy right now with the SVM. So also to keep in mind that it's not because there are newer models, it means that we are always, to go after the shiny things if there are things that works even better and, are already proven in the industry. Cool. Another machine learning model that we have. So basically, it's what we say our brain server, which is a multi-arm bandit. And we are using Thompson sampling for that. And the objective of this machine learning model is to find the best creative for every context. So it's using purely contextual data. So when we are going to show an ad for an user, let's say that we have 4 options of different ads. So the model, it's going to find out which is the best creative to serve for this specific person. How we use it? When we use this Thompson sampling, which is a Bayesian algorithm, usually optimized towards click or conversions, depending of the KPIs of the campaign. And the feature, as I said, this is contextual data. So basically HTTP requests, but also maybe campaign data, or some enrichment data that may have like weather or URL classification, for example, that we can do in real time. This is a real-time model. And basically, let's say if we have this new user that's coming, which is coming from Atlanta, and it, browsing through a mobile, which version of the ad we are going to serve her, right? I mean, in that case, it will be ad 4 because the model has learned that, for Atlanta and mobile, usually ad 4. The creative number 4 works better than other creatives. So, it's like some sort of multi-arm bandit that optimizes for the creatives to be shown in real time. So that's a quite powerful model. And it has been used in production for the last 3 or 4 years. So it's quite a strong model. And finally, another one machine learning model that we have is the domain cluster ones. What it sees here, like a painting, it's not that. It's basically the visualization. It's difficult to visualize, thousands of clusters with millions of URLs. But what it tries to do, this model, is find the category of the domain by using clustering model and browsing patterns. So what we use that, it's some sort of semi-supervised model because that's needed some sort of labeling initially, so you can understand which is the cluster, the meaning of the cluster in that example. For example, we are using the IAB taxonomy in order to classify that. And some of the internals is that we are using word2vec in order to understand the URL, what is the meaning of this URL, so to understand what can be the topic that is that we are talking about. And basically k-means also a classic model to make the clustering works. So I think that's basically one part of my presentation. So I can go now to some of the questions I think it pop up. One of the questions I've received is what amount of data does your system process per day? So per day, we are receiving more than 300 million of events. So it's right now it could be around 350, 100 millions per day. Yeah, so huge amount of data. Usually that provides a lot of strong insights because you can rely with a lot of data uh, to make sure that your assumptions are correct, right? And also when you're doing machine learning models, you can set up your train test data sets properly with a nice size batch. But on the other hand, it makes it difficult also for these big scale. Sometimes it makes harder to process jobs. So we are always trying to find how to optimize things and make our jobs and processes more performant. Cool. Another question that I had is, what will you like to see emerging in big data technologies? What will you like to get to make big data live better? Well, that's a very philosophical question. Well, I will say that one of the problems we have in big data, it's usually the expectations on the data. So I will say that data quality is one of the problems that I've seen in different industries. All the industries they have the same problem. It's more a problem than usually in some industries. You may have companies that they don't have enough data, and for them maybe it can be a problem. From my point of view, the main issue in the industry is data quality. To be sure, I mean, usually it's data that comes in a variety of formats. So making sure that the data quality is that what you expect is the challenge. That's why also we are using different items in order to make sure that the data is in the best quality or best shape as possible. For example, we are using a lot of Grafana to manage real-time reception of the data. So we are actually, as I said, we are receiving these 3+100 million of events per day. So we can know if we are receiving the right amount of data in real time. So we can also be able to react quickly when something is not working properly. But from a data perspective, the data quality, we are also using some external tools. We also in the last months, we already began to work also with an open source project that also I recommend, which is called Great Expectations, which is a tool also that helps you to double check that the data that you have is at least as consistent as possible by managing, I'm expecting that the size of the data set should be this one. So it provides you with a lot of additional topics and quality controls. But at the end, yeah, I mean, from my point of view, data quality is the big problem we have in big data ecosystems. Yeah, I think that's all the questions that we have that pop up right now. So you have time yet to make some additional questions if you want. As I have some spare time yet, what I'm going to do is, I had some additional slides just to show you what are other things we are doing in Ivory Theory. And, this is a topic that is quite relevant still today. We started to do some data explorations using our data during when COVID-19 started. This is also helping, different industries to understand how COVID affected them. So, for example, for car brand searches, what we see is that there is, a correlation between COVID searches and automotive interest. So, automotive interest in automotive topics decreased during mid-March more than almost 70%. So you see that this is the type of tools and exploration analysis that we also typically do. So we can also share that with different brands. Even on the LinkedIn page, we share some of the findings that we find. For food delivery, it was also something which was easy to understand, right? When it started COVID, food delivery also had a huge increase for that specific reason. We have seen afterward, this slide is from, it ended 24th of March, but after that, on the last months, it went down a bit, the food delivery topic, but not as previously. So yeah, it's still a hot topic. Also, we are able to see, how many days people usually convert from the last ad view. So when the last time that they see an ad. So, and the changes that we have seen before and after COVID. So people usually have more time to review e-commerce and review laptop reviews maybe, or other type of reviews of the products. So they use now more time before purchasing than before. So that's something also that we have detected in the a few months back. So yeah, that's everything that I have to share. I will come back to the Q&A part to see if there is a new question popping up, which I'm not seeing right now. So yeah, I mean, basically that was all from my side. So thank you for your attention, and we will have also a session in ask anything session. So yeah, I mean, we can ask other questions on that session as well in Zoom. So thank you for all your attention.